So let's look at the function f of x equals 1 over x. Okay. Now the graph of this function for positive values of x alone, I'm not considering the negative values, looks like this, more or less. This is asymptotic to the x-axis, so the longer it goes on, the closer it gets to y equals 0. Now, what's the area underneath the graph from x equals 1 to x equals infinity? Well, what we do is we simply say that the area equals the integral from 1 to infinity of 1 over x dx. Now you could be saying to yourself, well, hang on a second, we can just see that because this is asymptotic, logically it's going to be infinity. But if we just wanted to prove it to ourselves so that we know that the general method works, we'll do it through calculus. So, continuing. We know that the integral of 1 over x is ln of x, limits 1 to infinity. So that's going to be ln of infinity minus ln of 1. In other words, infinity minus 0, which is just going to be infinity. No surprise there. Now suppose we've got the same curve of x equals 1 over x, still to the same point as 1, but we rotate it through 360 degrees. We want to find the volume now encased by the curve from 1 to infinity. Well, what's the equation for volume? Well, it's simply volume is equal to pi times the integral with the limits that we are interested in this case 1 to infinity, of y, 1 over x, squared dx. So writing that out, we get pi 1 to infinity 1 over x squared dx, which is then going to be pi multiplied by the definite integral of minus 1 over x, again bounded 1 to infinity. And then we try evaluating that. We don't just try, we can actually evaluate that. We find it's minus 1 over infinity minus 1 over 1. You can see where this is going. So we look at this and we say that it's simply 0. Then minus 1 over 1 is going to be plus 1. So really, we find that the volume is pi. So an area that is infinite, rotated around 360 degrees, in this particular case, is equal to pi. Maths works out, but how does that work conceptually? I'll leave that to you to figure out.